Hey guys, so for our physics project, we're going to be implementing a Nerf gun, and we're going to be talking about various physics concepts throughout the video. So let's get right into it.
So in this video, we're going to be shooting the Nerf gun from two positions. So the first one is going to be shooting the Nerf gun from its full potential, and the second one is going to be like this, shooting it from 3/4 of its potential, and you'll see the difference in how the dart flies. So the dart flew into two different distances because of something called elastic potential energy, which is represented by the equation 1/2 kx squared. K represents the stiffness of the spring and is unique to every spring. X represents the stretch or compression of the spring, which ultimately stores the potential energy. In our scenario, the spring is being compressed and then released once the trigger is pressed. We have shown two different scenarios in our project. The first scenario compresses the spring to its maximum compression, while the second scenario compresses the spring to 3/4 of its maximum compression. The greater the value of x, the greater the potential energy. In the first scenario, the x value is greater, and therefore, as you can see, the bullet was shot higher up into the air. The second one also went high into the air, but was only 3/4 of the length, ultimately showing that potential energy before release was less than the first bullet.
Okay, so the next physics concept I'm going to be speaking about is projectile motion. A projectile is an object upon which the only force acting is gravity. A projectile is an object that once projected or dropped continues in motion by its own inertia and is influenced by only the downward force of gravity. In our scenario, the dart is traveling with a parabolic trajectory due to the influence of gravity. As the dart completes its motion, we have to keep in mind that the horizontal motion of the dart is independent of its vertical motion. There are no horizontal forces acting upon the dart, and thus no horizontal acceleration of the dart. Although, when talking about the vertical components of our projectile, there is a vertical acceleration caused by gravity, which is given the value of 9.8 meters per second squared down. Lastly, I would like to speak about the free body diagram of our projectile. The free body diagram of the dart in motion would show only a single force acting upon it, which is labeled the force of gravity. Regardless of whether a projectile moves downwards or upwards and rightwards, or downwards and leftwards, the free body diagram of the projectile is still depicted in the diagram to the right.
Newton's three laws of motion can be applied differently to the firing of a Nerf gun directly in the air. Newton's first law of motion states that an object will remain at rest or move at a uniform pace in no acceleration unless acted upon by an unbalanced force. When a Nerf gun is fired, the foam bullet is a projectile, which means that there is only a force of downward acceleration and downward gravity, which is the force of gravity that is acted upon on the bullet. This means that the object will travel in a parabolic path before coming to a full rest on the ground. Newton's first law ties directly to Newton's second law through inertia. The more inertia a bullet has, the more force that will be required to accelerate it. Therefore, an object with higher mass will accelerate to a lesser value, meaning it will travel to a lesser distance than a lighter bullet would. Finally, Newton's third law of motion states that for every force exerted on the second object, there will be an equal and opposite force exerted on the first object. When firing a gun, the recoil from firing a gun will have an equal and opposite force on your body as it does with the firing of the gun, justifying Newton's third law of motion.